What is up, guys? Welcome back to O'Neill Code. Today we're going to be taking a look at how the Huffman coding algorithm works, and we're just going to jump right into it. So this algorithm is a lossless data compression algorithm that takes advantage of high-frequency repeated characters. The purpose of it is to minimize the file size as much as possible. Now, since the English language has characters that repeat more often than others, this algorithm is super optimal and makes encoding text files very efficient. It's commonly used as backend to other compression methods such as MP3s, JPEGs, and DEFLATE. But how does it work? So the algorithm will create variable length codes for each character. The character with the highest frequency will have the smallest length codes as they are repeated more often. Characters that are less frequent will have longer length codes as they won't be found in the file as much. So let's look at this phrase subscribe here. If you look to the right, I put the final encoded version that we're going to get from the Huffman algorithm. So it's going to be a length of 43 binary bits. So that means in storage it's going to be 43. Now over here, let's say these are ASIC characters. There's 14 of them, so 14 times 8 is 112. Now 43 is about 60% smaller than the original. So this is what the Huffman algorithm can do. It can take a phrase like this and make it 60% smaller. It isn't always 60, but it's usually pretty good. And this is why it's used all over the place. So let's see how we can actually do this. We can do it by first finding the frequency of each letter. Once we do that, we're going to create this chart here. And we're going to find the most frequent ones. We have 3. Here for E, we have R, B, and S having 2, and the rest have 1. And don't forget this space. That is included in the phrase, so you have to include it. So, since we found that, we can start by creating the Huffman tree. We'll do that by listing them from greatest to least frequency. So we can do E, 3, S, 2, B, 2, R, 2, U1, C1, I1, space 1, and H1. So now let's start by creating the nodes. So what we're going to do is we're just going to add the frequencies here. So 1 plus 1 is 2. 1 plus 1 again is 2. 2 plus 1 is 3. 2 plus 2 is 4. Now over here 3 is the least, so 3 plus 4 is 7. Now we're going to come back over here. 2 plus 2 is 4. 4 plus 3 is 7. And finally 7 plus 7 is 14. And that's going to be the root of our tree. So this is our Huffman tree. Now we just need to get the codes from it. So this is what we can do. We can give each left a 0 and the right a 1. So we can go 0, 1, 0, 0, 0, 1. And since there's nothing left to go over here, we know that this is the code for E. It's going to be 0, 0. Now let's keep going. We can go 0, 1, 0, and 0, 1, 1. Now we found the codes for S and B. Now we can go up here. 1, 0, 1, 1. 1, 0, 0, 1, 0, 1. 1, 1, 0, 1, 1, 1. 1, 1, 0, 0. 1, 1, 0, 1. 1, 1, 1, 0, 1, 1, 1, 1. Alright, so we got all of the codes here. So now you can see that E is the most frequent and it has a length of 2. While these over here that only frequency 1 have a longer length. So when we encode this, the more frequent ones are going to have less of a length, and that's why it's so small. So let's see how we encode it. If we were just use this and start encoding, we could do 0, 1, 0, next to be U, so it would be 1, 0, 1, then it would be B, 0, 1, 1, and it would just be up like this and keep going until you reach the end. And you'll get this long binary string. Perfect. But let's say we were given this, we encoded it, and we need to get back to here. So we need to decode it. How do we do that? Well, we're going to need this tree and all of the codes for the different characters. So let's start. We'll start up at the root, and we'll go in the beginning. So we go 0, follow the tree right down. 0, 1, 0, 1, 0. So that's an S. Now we start again from the top. 1, 1, 0, 1, 0, 1. U. Top again. 0, 0, 1, 0, 1, 1. B. Top again. 0, 0, 1, 0, 1, 0. S. We'll do one more. 1, 1, 1, 1, 1, 0, 1, 1, 0, 0. C. Perfect. That was a length 4. That was even longer. So if we keep going, we're going to get each of these will eventually hit a code down here, and it's never going to be the same because there's no prefixes. You'll always get the unique character that you want. So that's the awesome thing about this algorithm. So you're going to go through and you'll eventually get back to here. So that's how easy it is. You're just going to create this Huffman tree using the most frequent letters to the least frequent letters. You're going to create it, and that's how you'll encode it. And to decode it, you just take what you have, follow the tree, and you'll get back to what you had. So you need to remember, you need these codes and you need the tree if you did encode it. So that is the Huffman algorithm, and that's how you encode and decode it. Hopefully you guys understand it. If you have any more questions, please let me know. If you liked the video, please give it a like, and if you want to see more videos, hit the subscribe button. I plan on creating another video which will actually be coding this algorithm in Java, so look out for that. Peace out.